Good morning everybody, and today I am going to tell you about the maxima and minima of a function of three variables x, y, z. That means under what condition a function f of x, y, z will attain maxima or will attain minima at a particular point. Okay, so this is the first theorem. A function f of x, y, z, it is a function of three variables x, y, z, has a relative minimum at alpha, beta, gamma if the function is continuous function and del f by del x is equal to del f by del y is equal to del f by del z must be equal to 0 at alpha, beta, gamma. Okay, we have to test the function, we have to test for relative maxima and minima of the function f of x, y, z at alpha, beta, gamma. That means point is given. Okay, so here the third bit is fxx, that means del square f by del x square is positive, and fxx, fxy, fyx, fyy determinant must be positive, and here. And how to write this determinant? See here, x is equal to 1, y is equal to 2, z is equal to 3. And in matrices, you are writing a11, a12, a13, a21, a22, a23, a31, a32, a33. This is same as this one. See here, xx, xy, xz. 1, 1, 1, 2, 1, 3. That means with 1, I am taking 1, 2, 3. With 2, I am taking 1, 2, 3. With 3, I am taking 1, 2, 3. Similarly, with x, I am taking x, y, z. With y, I am taking x, y, z. With z, I am taking x, y, z. Okay, so this one is the third order matrix determinant, and this one, and this part is the first part. And if all the three are positive, then a relative minimum will be obtained. And for relative maxima, see here, I am only changing here. The next theorem is, this one is maximum, and this quantity will be negative, and this quantity will be negative, and everything will remain same. And the first two properties will be same, and here this one will be positive, and only fxx and the third order determinant will be negative. Okay, so these are the two conditions for maxima and minima. Okay, so let us see an example. So let us see this example. Discuss the behavior of the function f of x, y, z equal x power 4 minus y square z square plus x, y, z minus x square minus 2y square minus z square are 0, 0, 0. That means alpha, beta, gamma is 0, 0, 0. Okay, so this is a polynomial in x, y, z, so it is continuous. Okay, so the first point is over. Now see here, fx, del f by del x, del f by del x is 4x cube. This one is 0, there is no x here, and this one is yz. Then this next one is minus 2x, this one is 0, this one is 0. And fy, what is fy? This one is 0, minus 2y into z square plus xz. This one is 0, minus 4y minus 0. Fz, this one is 0, this one is minus 2y square z plus xy minus 2z. Clear? Now fxx. So what is the value of fxx? This one is 12x square, this one is 0, this one is minus 2. fxy. Okay, fxy. That means what is the fxy? This one is del square f by del x del y. Del square f by del x del y. That means del by del x of del f by del y. Del by del x of, this one is, I can write del by del x of del f by del y. So del f by del y is this one, and you have to differentiate this one with respect to x. So there is no x here. Here it is only z. This one is 0. Okay, and here fxz. That means derivative of del f by del z with respect to x. That means this one. There is no x here. Here only it is y. So this one is 0. So f yx. That means with respect to y, you have to differentiate which one? Fx. This quantity. With respect to y, there is no y here. Here it is z. This one is 0. Fyy. That means this one. You have to differentiate with respect to y. That means it will be minus 2 z square minus 4. f yz. fz is this one, and you have to differentiate with respect to y. So minus 4yz plus with respect to y, that means x. This one is 0. Okay. Now f zx, fx, and you have to differentiate with respect to z. This one is 0, this one is y, this one is 0. F zy, this one we have to differentiate with respect to z. It is minus 4yz. This one is plus x, and this one is 0. And f zz, this one is minus 2y square with respect to z. This one is 0, this one is minus 2. Clear? Now at 0 0 0, your second point, if you put x is equal to 0, y is equal to 0, z is equal to 0, fx will be 0. This one is also 0, this one is also 0. That means fx is equal to 0, fx is equal to fy is equal to fz is equal to 0. Your second point is over. Now the third point, fxx. If you put x is equal to 0, then it will be minus 2, less than 0. Now fxx, fxy, fyx, fyy, the second order determinant. What is the value? Let us see. Fxx minus 2, fxy, it is 0, fyx, it is also 0, fyy is minus 4. So it will be 8 positive. Now third one is fxx, fxy, fxz, fyx, fyy, fyz, fzx, fzy, fzz, determinant. So let us see these four values already I have written: minus 2, 0, 0, minus 4. Then fxz, it is also 0. Then fyz, yz, this is also 0. Then fzx, it is also 0. And fzy, this is also 0. Fzz, this is minus 2. So it will be this and this and this. So minus 16, which is less than 0. And this is the condition for maxima. That means f is maximum or relative maximum at 0 0 0. Clear? So first of all, you want to find out fx, fy, fz, and whether these three values at 0 at the given point or not, you want to test. And then you want to find out the second order partial derivatives and apply these three cases. Okay. So in this way you can test the behavior of a function of three variables at a given point. So I will give you some questions and do these problems. And in the next class I will tell you how to find out the maximum and minima of a function with given condition. That means find the maximum or minima of a function f of xyz or f of xy with some conditions. Either the condition may be one condition will be there, or two conditions, or three conditions will be there. Okay, so that is the very important part. Okay, thank you.